Well, hello and welcome to TDL podcast live stream. Today we'll be looking at this is the episode number 3 of looking at AI video tools, and now we are getting some idea as to how to proceed in terms of generating a good AI video. Now we also have understood that if we are using Cog Video as a model, then we can generate some nice sort of animations and videos, so that's good. Now we will also, I mean, like, at this moment it's obviously very clear as to how to work with these models. We have to, because most of these models are image to video models, so we need the images. How do we get the images? That is what I'm here to check today. So if you have missed the previous videos, then you can go and check it on relevant platforms like LinkedIn, Instagram, X. We are posting everywhere. So you can have a look there. And if nothing, just drop me a comment. And I'd like to, I'll help, I'll put you in the direction to find those earlier videos. Now today we are talking about stable, like we are looking at text to image models, and that's why I'm at Hugging Face, and we will take it forward from there. We will run some models today, and the goal would be to generate myself talking on a camera in space or something like that, in an astronaut suit or inside a space station, whatever, some funky stuff. So that seems like a good challenge to get started on, and let's get started. All right. So here you can see that we have, like, I'm at Hugging Face now and looking at different models. The first model that I'm looking for is, of course, text to image, and Flux is the first one that comes up here. So seems to me that stable diffusion and Flux, those two we already know are very, very good. But what about the other ones? Like, just having a look around, Flux, I don't have too much experience working with Flux. Last time in the stream I saw this page. We need to access repository, and we have access to the repository now. Flux model are available via API, so we can install the diffusers, and then uh, Flux dev. Okay, so there are few of them. Uh, so this seems to me as the first one. Then there's another one, Black Forest Lab Flux SNL, SNL, and what is this? XML is 12 billion parameters rectified flow transformer capable of generating images from text description. For more information, please read our blog post. Let's have a look. I'm not sure how good the Flux is. Stable diffusion, I know that because stable diffusion has been around for some time now. It's been at least few years. Uh, in the last year, I got exposure to stable diffusion, and more than a year ago now, and it's quite good when it comes to building the high quality stuff, like high quality videos. It is good, and also we can train our LoRa and make sure that the model generates us in the video or image, mostly image. So that is my exposure with stable diffusion. But seems to me that Flux is doing really good because it has a million download just in the last month. So that's nice. Trained using latent adversarial diffusion distillation. Okay, so we are looking at the blog post announcing for Black Forest Lab. Today we are excited to announce the launch of Black Forest Labs, deeply rooted in generative AI research community. Our mission is to develop and advance state-of-the-art generative deep learning models for media such as images and videos, and to push the boundaries of creativity, efficiency, and diversity. We believe that We believe that generative AI will be fundamental building block of all future technologies by making our models available to wide audience. We we want to bring its benefit to everyone, educate and the public, and enhance trust on. So it's nice. Okay, so I'm off the right off the bat. You can see that the images are very creative and generating some photorealistic humans as well, photorealistic scenes, and very creative in terms of what it is generating. So definitely worth checking it out. Funding successful closure of first seed fund round of $31 million. This round was led by our main investor, Anderson Horowitz, including notable participation from angel investors Brendan uh, Irib, Michael Ovitz, Gary Tan, Timo Aria, okay, Vaden Colton, another renowned expert in AI research and company building. We have received follow-up investment from General Catalyst and March VC to support. All right, that's nice. So where are we right now? Stable Flux One family, and there is ELO score. So Flux One Dev seems to me is on the very high, then Flux One Pro, and then there are a bunch of different Stable Diffusion 3 Ultra, and then Ideogram, Tali. So seems to like what they are highlighting is that model is doing really well across this ELO score benchmark. I don't know what is that ELO score benchmark, but we'll know it soon. We released the Flux One suite of text to image models. Okay, fine. So we are seeing that these models are very good, and the cost wise, as you go forward to the Pro, then the cost is lower. But we can see that the dev has very good uh, performance. So definitely worth checking out, and we will be. That's why I was a little bit confused because there are two models, SKNL and dev. We'll probably try both and see which one works out best for us. So what is this happening here? A flux model variant supports a diverse range of aspect ratio and resolution in 0 0.1 and 2.0 megapixels as shown in the following example: 0.1, 0.4, 1.3, 2.0 megapixels. Up next, SOTA text to video for all. Today we release the Flux One text to image model suite with their strong creative capabilities. Those models will serve a powerful foundation of our upcoming suite of competitive generative text to video systems. Our video models will unlock precise creation and editing in high definition and unprecedented speed. We are committed to continue pioneering the future of generative media. Okay, so seems to me that they are going to release text to video systems, and that will be quite nice because it fits the our larger theme of this live stream series, that we want to create really good text to video videos. So definitely something to check out. All right, let's get started on this. So first we will see, we'll take this model for a spin. Flux 1.0, Flux 1 dev. I mean, like, I'm half interested in generating output can be used for personal, scientific and commercial purposes as described. Okay, so that's nice. The license is very uh, yeah, license is very open. It's the same thing here also, Apache 2.0. There is a little bit of difference, right? So I'm not sure which one is better, which one is not. We'll probably see and compare them as we work with it. So first thing first, don't want to waste too much time. Let's go to Colab. And one thing that is making me think and having confidence on this model, and that is because the model has good number of downloads, and that is generally a very good indication of if the model is good. And just wanted to very quickly check the stable diffusion text to image, and stable diffusion 3 medium stability AI coming right from the source, and it has like one not even one, but it has like 86,000 downloads versus a million downloads. So definitely worth checking it out. Let's give it a shot. We come back here, we create a new notebook. So in case if you want to if you want access to this notebook, first of all you can follow along and do this, because essentially I'm just following the documentation and showing you the process. So otherwise, very soon, you like by tomorrow, these notebooks are going to be available on my personal blog, which is thedesiloops.com, and there you can also find it. So let me go quickly and set this up. So this one is called Flux, flux.1.dev, and let's go. This is the first time. I'm very excited to have this model running, and the first time I'm doing it. So that will be good. I made a mistake, I believe, because I did not choose the type of instance we need. Like usually, I take the best instances in the system, so why not do that now? I'm going to change runtime and take the best runtime. So A100 is the best right now in Colab that I have seen. But if you have to use even better GPUs, then then we have to jump into something more custom like RunPod or things like those. But we don't have to right now, luckily, because usually I have seen this 40 GB is more than enough for running simple like medium sized models and getting really good output. So today, earlier we were looking at latest version of Llama 3.2, and that was really awesome. That model worked very well, and we ran it on Colab. So, so going to copy some things. So usually what I do is I set up the model separately, and then uh, so here the model is ready. So like not ready, but we'll just separate the model. This is the pipe, so we need a pipeline, and the pipeline will be notebook does not have access to HF token grant access. So you'll have to set up this HF token on your Google Colab, and this token actually isn't simply this token just gives you access to the Hugging Face registry to download these models essentially. So that is that. Okay, so it's downloading couple of models. So seems to me like it's similar to stable diffusion where it uses multiple models to do multiple things, and it all works under a simple pipeline or complex pipeline. So there we are downloading 10 GB of first model, and then second model is about 24 GB. That's quite large for any model. So that's like 34 GB download, and probably 34 GB residing on GPU at least. So that is that, that gives you some idea about how much GPU provisioning that you should be doing. Okay, suddenly all the models have become very slow, like the copy is becoming very slow for some reason. It's picking up now, but like the download speed was too slow for a moment. If you are getting like 5 Mbps, 10 Mbps, it's going to take forever to download these models. These models are really big, so we can't even compare. Like at this moment I am on a quite good speed, like 300 Mbps, and that is nothing compared to what speed that we are seeing here. This is at least, if you're seeing like 100, probably like 1 Gbps, 2 Gbps lines. This is at least 2 3 Gbps line if it is giving us 200 Mbps download. So I think we are almost done with the model download. Now prompt a cat holding a sign that says hello world. Okay, so what are the limitations? This model is not intended to or able to provide factual information. As a statistical model, this checkpoint might amplify existing societal biases, of course. The model may fail to generate output that matches the prompt, of course. That is how these models work. Prompt following is heavily influenced by prompting style. Mhm. Okay, so what we cannot use it for? Alright, we are ready. So we are going to generate the cat. Ah, what did I do? I think I made a mistake. I did not copy. I should have copied. Uh, Prompt a cat holding a sign that says "Hello World." This part. I have to copy. And GPU offloading did not happen for some reason. Maybe we have to say pipe.cuda. Save the some VRM by offloading model to CPU. Remove this if you have enough GPU power. Ah, okay. Okay. Yeah. Should have done that actually. Hmm. Okay. The image is processing. Hopefully we'll see the image soon, and then I'll upload the model to GPU. I mean, like it's already, I think that it has recognized that the model is, we have enough GPU computation, so the model has moved to GPU, and sooner or later we'll have the model ready, the image ready. I mean to say, because it's using 23 GB of GPU RAM, which is good. Now let's have a look at the image. Okay, so what was the prompt? Cat holding a sign that says "Hello World." Height, width we passed. Guidance scale. Inference step is 50. Max sequential length is 512. And the prompt. Okay. Okay. I mean, like it's not bad. It's a good image, I have to say. And also, I have to check its image to image pipeline, because especially if you're building images, you know, like generating images, you would probably want to use image to image pipeline also. Or you have to train the model in such a way that the image to image, or like it knows about you. Like say if I want to see myself, like Rajesh flying in space in an astronaut suit, that will be good. With that, why not we check it, right? First I'm going to offload the pipe to GPU. Pipe to CUDA. So we move the pipe to GPU. Okay, I know that. Okay, so we have moved it to CUDA, and we have to say here also, I think, CUDA to generate. Now we can see that we are utilizing more of GPU compute, which is 32 GB, and the image performance has not changed a lot. It's changed to like what, 13, 20, like very low. So that would be good if the image generation is faster. I mean, like faster is better in almost doing whatever, right? Okay, that is done. Okay, so the image is kind of similar. Quality is Same. Now what do we want to do with this? I have to say a man floating in space wearing, I don't know spelling of astronaut. Astronaut. Astronaut suit. Maybe it's not correct. Oh yeah, ASTRO. Okay. Astronaut suit. Uh, this looks like this notebook is having some problem, and that's not good because we may not get access to our stuff properly. Did we see something like this? GPU has, like, it's showing less GPU usage now, but suddenly now it's showing 23. Anyways, looks like the reporting metrics are a little bit wonky at this moment at Colab, but as long as we are able to use it, it's okay, I feel. Okay, let's give it a shot. What did we see? What did we get? Okay, I'm kind of impressed, but I want to see the face. To not suit, transparent helmet, uh, vibrant background. So see, this is how we will be able to do, right? So we have to say that this is the like we this is how we are supposed to composite our scenes, and then take this image to our image to video pipeline, and that would be whatever model that we decide to use. This moment I'm very much inclined to use this particular model. I like to, by the way, use open source models a lot, but but soon, like if you guys like, I can definitely create a video to cover the scenario in which you would want me to have a look at the closed source models, and how to create videos with that. You know, that would not be and essentially more complex than whatever we are doing. So it's actually, in fact, going to be easier. So here you can see that this is also another one, animate LCM, Mr. Video. But the problem here is what I saw. You know, generally you can't provide prompts. You don't really need prompts too much, anyways, because then you can just generate a lot of images and then composite the with the properly trained LoRa. That should be possible to generate a bunch of images and composite them with minimal animation. So that is also one way of creating videos. So then you don't have to essentially use something that gives you a lot more power, something like cog video, because essentially a lot of times it kind of messes up the prompt anyways. So it doesn't make too much sense to stick onto that for that reason. Okay, but how do we see the image? How is the image? Okay, see the color vibrant background it has got, but his face is not visible, and I wanted to have his face like visible. Also, Do we see anything? Doesn't make any sense, right? There's something, but mhm. Transparent helmet, vibrant background, astronaut suit with visible face. So prompting is something that generally with these models, prompting is a skill that will take some time. So as you work with the model, you learn how to prompt it better and better. And not necessarily one prompt will work for all models. So every model has its own, nuances and quirks. So you have to work around that and generate great images. If you're focused on, generating what you want model to generate. So yeah, that is what I wanted to say. All right. Uh, Sorry, I was looking at something on the other screen. So let's have a look at the image. Ah, this is so cool. This is something I wanted. So what do we see? Face is visible. That is great. Also, you can see some shading, maybe, maybe not. I don't know right now, but it is cool. And it's got the fingers right, which is a big problem with stable diffusion. If you know how to train its, equivalent of LoRa, that would be cool. Now, what do we want to do next is background, face, face, craft in the background on fire. A worried man floating in the space. Let's see what we get. So I want to create like a dynamic scene where dramatic scene where the you can say that something is not working, and then we see Earth here, which is probably not what we want to see, but that's all right. Ah, this is cool. This just reminded me, like, spacecraft in the background. What did I say? On fire. Man is worried. That is obviously clear. And he's looking at camera. The spacecraft has some fire, but not too much. And the details, doing very good job with it. And like this is so simple prompt. I think anyone can write a prompt like this. Like another one could be two cars in a car crash, sunny day, mm, uh, fire in the background, uh, people gather around. All right, let's see. No wonder why Flux is so hot these days. I mean, like, I see this model, and this model is incredible. Incredible. Definitely, it's a great candidate to build a build AI thing, and now we will be like after this car crash scene, I will be looking at multiple people, and it's got the fingers right also, which is a good like big thumbs up. I mean, like it would make sense that it gets it right anyways because stable diffusion did not get it right, but it was long time ago. So let's see what do we get. All right, let's have a look at the image. What did we get? Okay, not not too bad. I mean, this is not what I was imagining, but and this is definitely something that the cog to video model, cog video model will do excellent job. But now I wanted to change it. I want to change the. It's like very different car models also. Anyways, I want to say something like two cars in a car crash, sunny day, fire in the background, people gathered around. Two uh, uh, lux, not luxury, two expensive cars in a car crash. And also, so generally with these models, it's very difficult to get them to generate consistent and coherent image across the time. So there are a lot of videos on YouTube to do that with Flux. So definitely I'll check them out also. And because now probably in couple of streams we'll have our video ready, and so hopefully by tomorrow evening we can have the video ready, and then we can even create a commercial of something. But today, like this one, I want to create like something unique. I don't know what would that be, but let's see. Ooh, so cool. This is nice. The car body is not damaged, but they are in crash. There is fire in the background. They are not in crash, like two expensive cars in a car crash uh, with visible damages, uh, glass crack, wind shield, and what else? Debris, debris all around. Give it a shot again. Let's see how long it takes. I think the speed of the generation is also very high quality, high speed. It's generating at a good speed, I must say. Still generating. See, you can like generally it's taking what like 30 seconds to generate itself, like generation itself, and then it has extra things like maybe so like a minute for each video, each image. Now, if I have to generate like 50 images, it will take 50 minutes, take 1 hour, and 1 hour probably is not too much in terms of like cost. And then we take it and generate the videos. Okay, now we are getting into the crashed state because it's not able to have this visible damages, right? Like kind of getting problematic for it to do, but let's see more. Too expensive cars in a car, but still, again, if you that is the beauty with these models is you can definitely take these models and train them further to do like these kind of things if the model is not inherently capable of doing it, and that's one of the huge benefit of these open source models. Anyways, let's continue. Too expensive cars in a car case with visible damages. Too expensive cars in with damaged in an accident. Debris all around. Sunny day. Fire in the background. People gathering around them. Okay, so let's see. The last image was somehow better because it feels very weird if there is no headlight. So this model thinks that removing the headlight is equal to damages, which is quite weird. You don't want, like, I don't think that is good. Okay, so tomorrow, in the next stream, I'm definitely going to go into fine tuning of doing some things of these models to train it more, and then seeing if we can generate something. Like, basically, see, my goal is to generate my own images, so it's not able to do damages, which is weird, but it's fine. Can probably work with it. Next thing, yes, two people. I think what probably most of these YouTubers, they, like, most of the tutorial that we have around maintaining the similar, like, maintaining the same stability across the multiple images would be to save the logit somewhere. So after the generation, you can take some logits and save it, and then use those logits for the next video generation, and probably it will generate same people over and over. Two people shaking hands. Uh, One person in background having a funny smile. Oh, office indoors, laptop showing. I don't know what to show. Laptop showing. What do people see in the laptop? Emails. Email. Okay. A lot of things happening in this video, this image, and let's see if it can generate something that I'm thinking. Now I'm thinking not too much right now, but something like conspiracy kind of a feeling wherein you have two people shaking hand and entering into a business agreement where one person, I mean, both persons are naive, but somebody else is pulling the strings, and laptop is showing emails, just like for the for just adding some extra details. That's all. Let's see if we can get to any good state with this. Okay, let us see. No, it can't find the next person, which is a problem. Also, I mean, like, the bench generation is okay, but the person in the background is missing. There's no cunning. Ah, okay. I see what it is doing, because I said one person in background, so it's probably dealing with two people shaking hands. Many people are around. Office indoors, laptop showing emails. I don't know if we should use like like these periods, or we should use something else. Let me have a look at this now. If there is a way to do, if there is a way to do prompting, that will be nice. Many people are fine tuning it for many things. Uh, like what? I missed two lines. What is this? Story. Okay. Oh, they are doing. Okay. Hmm. I don't understand what this is happening. Performance across different sizes and scenarios, generation quality, flux, dev, other flux dev, floating pointers, 16, floating pointers 8 is much better than other quantized model, other quantized models. Speed. So what it is doing? Ah, it's probably doing it like this. It takes the image, right? Then you have to draw what you want probably, and then it just renders the proper image. I have wanted to check this Comfy UI actually. I don't know what this is, but I know I see it a lot on a lot of other videos. And if somebody wants, like, I don't know, okay, a lot of people are around and everything. People are in office indoors, laptop showing emails. Okay, not bad. Two people shaking hands, fully visible. I think the prompting will be something that will take me some time to understand how to do it properly with this model, like any other model, of course. Okay, are we done generating? No, almost. Okay, let's see what is the image. Not really. Two people shaking hands, smiling. Two smiling people shaking hands. Okay. So I wanted to also let you know that on Instagram, the stream is going to stop at 1 hour mark. So if you want to continue watching the stream, then you can go to any other platform and search for my username, Instagram username, and you will find me there. And then like you can continue watching if you find it interesting. Okay. So the image is ready. Hmm. So this is kind of better because now when you say smiling, then the model knows that we want to generate the face also, because without face it doesn't make any sense for me to ask for smiling. So the model is doing good. I don't know if it has like image to image capabilities. Image to image. Is Flux capable of? Okay, there is control net upscaler, which is fine. Surface normals, what we were looking for. Depth, surface normal. These things are probably for 3D stuff. Yeah. What does it do? Like you can take the image by just for adjusting. This model can be used directly with the library, so you can take an image and then, oh, I see. Then it can just prompt load image. Hmm. So what does it mean? Means that from surfaces normal, so you can generate the image. Okay. Probably it's this image, this model is not like not suitable to do whatever we want to do with it, essentially. Okay, so probably for image to image stuff, you would want to use uh, for image to image stuff, you may want to continue using stable diffusion. Now, probably what I'm next thing I'm going to do is flux. Uh, Keep consistent character. This flux and describe major physical features of the prompt. 19 images will save, characters will show up. This is a huge weakness of flux, no diversity. In it has no diversity in person it's generating. So because it's easier problem to solve than too much diversity, a lot of nodes that work with 1.5. SWs and XLRs haven't been updated to be compatible with Flux yet, but like those, I should be it should be possible to increase prompt diversity by injecting a small amount of noise into some of the unit tension layer. Flux doesn't have units anymore, it's completely different architecture, and the problem is that it's missing information about different phases. So when you want a new phase, example by Alora, you need to provide more information during the training as it must learn a picture and not how to assemble a picture out of stuff that it already knows. We'll see once LoRa training has got wide adoption, people have started to gain experience. Sorry. Okay, so we are discussing the nitty-gritty details of this model. I will definitely want to do it off the stream and then come up with some solution. I thought so, like face swap and all. I'm sleeping on this technology a little bit. So face swap, again face. What is this model? It's a model. Okay, what is this model? Hmm. Okay, it can do face swap, basically what it says. Okay, so there are ways to do that, but for a simple videos, simple AI videos, that would not be the right way to do, because in simple architectures, what you would want is you would want as little things as possible, not as many things as possible. So that's why I'm very skeptical of introducing new stuff, and especially when we are getting this close to execution. So I may go back to stable diffusion for that matter, and then continue image generation there, because Flux is good as it is. But if it is not, like if it doesn't give me, actually I have to check also how it does the how it does the LoRa, Flux, LoRa training, Flux, LoRa AI playground. So we are about to reach 1 hour mark, and I will probably close the stream today on 1 hour. In this stream, we have already seen Flux, and it's doing good. So it's doing good, decent work. Now it's asking for images and there and everything. Train Flux LoRa. It seems quite simple to do. Training your own Flux LoRa model. How? Model license training scope. Generally, in these kind of trainings, I just like to see. Just want to see if this is like what is the cost and everything involved. So cost $2. One training completes. Once a training Flux dev LoRa model on replicate how to generate images. So definitely that's something that I would want to do in the next stream, wherein I will take some images and then train this model to use my images, and then generate me in different scenarios. That will be nice. So something like, for example, if you want to train on, I don't know, like apple falling on Isaac Newton, for example, you can do that. You can, you can make the apple fall on him by training a LoRa that will actually. Mhm. Okay, I'm getting some ideas as to how to proceed with this. Uh, what else? Run will be under training with Python, blah blah. Perfect file. So, certain trigger word upload on Lal AI. 12 to 15 images of yourself, set training steps to 1000, specify a trigger word. Start training. When complete, copy the URL of the generator saved instance files to generate the images you trained to LoRa on. I mean, like, okay, fine, we can train the LoRa, that's clear. But what is the outcome? You know, Flux LoRa training, uh, Flux LoRa training example, right? Somebody tells me how to do it. Okay, so we are a noob. I mean, like, I saw Flux today. So where do we go with this? Image generator within the wild, using Flux model. Flux Snell. This video I'll teach you on LoRa three steps: basic, dataset description. So first I'll show you the image I generated using a fine-tuned Flux LoRa, and so here's a guy, and he's doing, what is this? Three images on top is trained on my photos. Bottom two are trained on shoe images taken from the internet. Oh, oh, that's so nice. Oh, that is that's giving me some ideas, right? Like, because if you have a product photo and stuff, like you can just put those photos in the model, train it, and then just use it. He's taking these images, samples of the training images, and it's generating good images. Okay, it's quite nice. Once you have the image, you should be able to caption it. Caption has to be very descriptive. You must describe the background, the attributes that are not specific to you in details. For example, shades, close bag, etc. During the experimentation, I found out that it's useful to describe environment like wind, etc. They interact directly with you in the images. Okay, nice. Okay, the photo Shakib man. So looks like. uh Okay, I'll probably take like a notebook and go to Colab or something. It's not like I don't want to pay that price, but I don't know what the outcome I'm going to get right this moment. So whenever a situation like this happen, I just like to take things on my own hand and just try, because if I'm going to use like say 25 minutes of, okay, maybe I don't know what resource requirements and all those things will be needed, but okay. Run the training notebook, open the Google Colab. So these guys are using Google Colab, which is nice. Load the workflow. You should be see the workflow loaded, like the screenshot below. Fine. Review the input parameters. Generate captions. I just want to know like what, like I just want to know two things: which computer that they're using, and which, like how much time. You know these two things, you can work out the cost. Says 15 hours. Okay. So running on L4 GPU instance, default takes 1.5 hours per 400 steps. So you can visualize the training results in Comfy UI like below. Okay. And usually how many people do? I think thousands probably. No, doesn't matter. Typically takes 1000 to 1500 steps to train a load of a Flux one dev. All right. Slow. But maybe if we go to, you know, faster GPU, then this process will be faster. If not, still we'll train the model and we'll do, what we are supposed to do with it. Fine. So that is our list of things to do. Is tomorrow we will train a model like LoRa for Flux, and then start generating myself into like different scenario space and all those things, and probably work on a story in the background also, and then we will create the AI video. This sounds good. So stay tuned to me on different social media wherever you are seeing me, and we will be doing the video generation tomorrow. It is exciting, and I did not know that we'll be able to generate a AI video this quickly. And I have really high hopes of doing this, because I know that we can even train the cog video. So maybe we'll not be able to finish the video tomorrow. Maybe we'll still have like some hiccups and issues, but sooner or later, like probably we'll be making huge steps tomorrow, and then a day more to train some cog videos and stuff like those. If we have to add some, uh, I don't know if I want to really do that, because I don't know if I want to again start working on AI music, but maybe I'll do AI music and AI audio generation, and then we will be creating this video and launching it soon. So that's about it on this stream. If you have any questions, any comments, any feedback, feel free to share it on wherever you are watching me. And thank you so much. I'll see you in the next one.